Okay, let's do it in the second example. Now it's a little bit more complicated. You compute the double integral. The integral function is 1. Esto es el volume, basically. The region R is bounded by c equal 1 minus y. This is a plane. This is a plane along the x-axis, because the x variable is missing here. And this is another surface, y equals square root x, and this surface c is missing. Therefore this is the cylinder along the z-axis, because c is the missing variable in the first octave. So let me try to do the sketch in 3D. It's a little bit complicated. Okay, I know that this is a plane bounded by the cylinder like that. Okay, so we have one face here, another face here, and the last face is the x, y plane, c equals 0. Okay, this is 3D. In 2D, I omit the c. C is missing. Therefore, y equal 1. That's this line. And this curve is y equal square root x. Okay? Suppose I want to set up the triple integral and that way. Triple integral. Suppose z simple. Z simple go from 0 to this. Okay, this is the c value corresponding with the plane, because the top part is always the plane. So it's from 0 to 1 minus y, get the maximum c. The c go from 0 to 1 minus y. And this is integral function 1. This is dz. Suppose now I go to the 2D. In 2D I make a decision to integrate in this direction. Entonces I go dy, this is dy, and dy will go from the square root x and 1. And finally we extend it in that direction, que es this point is the point 1,1. 1,1, this is this one value. This is from 0 to 1. This is one possibility. Another possibility, using also C simple, is que yo integrate in this direction. Again, but the double integral we are doing in that direction. Okay, let's do it. Triple integral and another possibility to set up. C simple. Okay, I forgot here. The y is this layer and the x is the last layer. Okay, the thing I want to change is using C simple again, this direction of the integration in 3D. So this stays the same. But this no. This change because I want to integrate first now with respect dx. The dx go here in that direction from 0 to the x value of this curve. This curve is similar to write x equal y squared, no? So say from 0 to y squared. Okay, this is was dx, and finally we extending in that direction. The y go from 0 to 1. And the answer is the same. after we were checking in decimals. Okay, entonces I want to explain now x simple. X simple is a integration in one direction parallel to the x, like that. Then you go to this que is 0 to the surface que is the x value of this x value, and x value is y squared equal x value of the cylinder. This is the x symbol, and the projection P is onto the YZ plane. Okay, let me set out the first integral. Triple integral. You integration first multiply the x because it's x symbol. The limit is from 0 to the x value of the cylinder, case y squared. I did the first layer. The second layer, when I don't know, I go to the projection. And the projection we have two options: integration in this direction and expand in this direction. Okay, in this case, integration dz, and dz vary from 0 to 1 minus y, okay, is the equation for this line, and this is 0 to 1 and x. Okay, this is one possibility. Another possibility using x simple also is triple integral from 0 to y squared dx. But you make a decision integration in this direction. In this direction is y. Entonces y dy here, and dy vary from 0 to 1 minus c. Okay, it's the same equation here, but solve for y. Now, finally, you're extending in both directions from 0 to 1 dx. Okay, it's another way to set up the triple integral. Okay, the last possibility is using y simple. Y simple, I integrate parallel to the y-axis. So you integrate for the wall of the cylinder to the wall of the plane. Okay? And the projection P is onto the CX plane. Or something like that. Let's go to the equation. The equation is, this is the equation, plane and cylinder. But if you manipulate a little bit, C is equal 1 minus, instead of y you put radical x. Okay, this is the projection. So you, not necessarily y0, you try to eliminate y in the equation. Okay, and this is the square root. Okay, this is 1 here. But this is, reflection, and also vertical shift. That this is like that. This equation is C is equal 1 minus radical x. Okay, ready. Let me set out the triple integral in two different ways. Okay, now it's y simple, so it's dy first. The y go from the y of the cylinder, que is this, radical x, to the y of the plane, que the y of the plane is, look, let me manipulate here, I believe 1 here, y is equal 1 minus c, no? Here, 1 minus c. Okay. Now I go to the double integral. Double integral, I will do in this direction and extend in this direction. Okay. I go, this is dc, DC direction. Entonces I go from 0, 0, 0 to the level que es 1 minus radical x, and finally we extend it from 0 to 1, dy from 0 to 1. Okay, another possibility is doing exactly the same. The y simple direction is from radical x to 1 minus c dy, but you change here. Now your integration from, suppose this direction, from 0 to this in direction x. The direction x is, let me see, so for x here, that from 0, you go from 0 to the x value, x here, entonces, let me see, I move radical x, and you put 1 minus c, and square both sides. X is equal 1 minus c, 1 minus c, minus c square. Okay, this is another limit of x. 1 minus c square. And this layer is dx. And finally, dy go in this direction. Dy, no, sorry, this z. This go from 0 to 1. Super fantastic. Okay. The most important thing is, in any problem, you don't need to do it a different way. You select the way that you consider better depending on the problem. O sea, Z simple, Y simple, or X simple. I recommend strong you try first C simple.